Now let's start the second part of today's lecture. We are going to define a new language called Expert. Well, the name remains the same, but the language constructs are different. We are going to call this language Expert, and it has 5 language features, 3 for arithmetic expressions, and 2 for identifiers. These black 3 cases are just the same as before. So you should be familiar with these 3 by now. The first case is a number, the second case is addition, and the third case is subtraction. As usual, this expert and num, expert, they are non-terminals. And these quoted 따옴표로 둘러싸인 애들은 terminals. Open, plus, close, minus, like that. So we knew how to make an instance of an expert by using these 3 cases. Today, we are going to introduce 2 more cases to introduce an element of the set named expert. The new cases are identifiers, right? This is for introduction. This is for use. As I told you before, whenever we discuss new concepts in this course, programming languages course, this time identifiers, there are highly likely 2 language constructs. Language constructs meaning, language construct. When I say a language construct, meaning one of these thingies to create a language. Okay, so now today we are introducing 2 language constructs, one for introducing a new name, another for using a name. When we introduce a name, we are going to use this concrete syntax, meaning open curly brace, VAL value, a new name for the new identifier, equals, that's the initialized value. What's the initialized value of this identifier? Oops. The value of this expression. Semicolon, second sub-expression, close. When you use a name, the defined name here, you're going to name it. Let's look at some concrete example that's going to help you to understand what I just talked about. Is this an expression? Meaning that, is this an element of expert? Let's see. If you want it to be an element of the set named expert, it should be one of these 5 cases. Is it a number? No. Is it an addition? No. Why not? Because it does not start with an open parenthesis, meaning that it's not a subtraction. It's not an identifier. So the whole thing should follow the syntax of the 4th case. Let's see whether it is. It's open, close, open, close. Oh, that's good. It has VAL. Oh yeah, it has VAL. That's good. It has a name. Oh yeah, that name should be this X. Pyong. And equals. Oh yeah, equals. And the first sub-expression. The first sub-expression. Okay, that should be this thingy. And then semicolon. Oh yeah, here's semicolon. Second sub-expression. Oh yeah, that should be this one. And then close. Oops. Sorry. Yeah, oh really? Then, let's see. The first sub-expression is 1 plus 2. And the second sub-expression is x, open x plus x close. Really? Are they really expressions? Let's see. It starts with open, so it's going to be either the second case or the third case. 1, we now know that 1 is an expression, plus, okay, we know 2 is a number, which is an expression, close. Oh, that's good. Similarly, open one of these two. X, is X an expression? Is X an expr? Oh yeah, because ID is an expression. So ID is an expression, which is an expression. Yeah, very good. Plus another expression, close. Do you see that? Now that we know this is a valid expr, right? It satisfies the concrete syntax. Then what's the meaning of it? Let's see. X's value is the value of its right-hand side expression. Open 1 plus 2 close. So you know that's 3. Yeah. Then what's the value of X here? What's the value of X here? That's 3. What's the value of X here? That's 3. If you add them, that's what? 6. Easy, right? One more time. Because we know that this whole thing is an expression, we should be able to evaluate it. We know that num is a number. The value of an addition is the value of the first sub-expression and get the value of the second sub-expression and add those two values. How do we evaluate this local identifier declaration expression? We first evaluate this first sub-expression, get the value, and remember that this name has that value. Yeah, equals, right? The value of this name is the value of this expression. And while evaluating this expression, you may use this name. Otherwise, you wasted your time. Yeah, even though for what I just said is that you may have this thing, val y equals 42, and then 8 close. You can do that too, right? The first sub-expression has the value of this identifier, and then you evaluate the second sub-expression. While you're evaluating the second sub-expression, you may use this name or not. When you use this name, the value of it is going to be the value of this expression. Yeah? So, okay, here, the value of the whole expression is the value of the second sub-expression, which is 8. Is it clear? What about this one? Because is it a valid expression? Yeah, right. Because it's an ID. X is an ID, which is a subset of expr. So it's a valid expr. But what's the value of this name? Do you know? Do you know the value of X in this code? This is the entire program. What's the value of X? I don't know. It's an error. It's a free identifier error. How about this example? It looks complex, but not really. It has the first sub-expression plus second sub-expression. Is it a valid expression? What do you think? Think about it. What do you think? Is it a valid expression? Not really. It does not satisfy the concrete syntax of expr. Do you see that? Right? Because, yeah, if it's an addition, we need this addition. Then we need this first and second sub-expression. It looks like this one and this one, those two are valid sub-expressions. And, you know, these semicolons, we do not need semicolons in Scala, but this expr requires that, like that. What's the problem? It does not have open close. It does not have open close. Okay, but let's assume that we have it. Yeah, it's a typo. Then, how do we evaluate this? When we have an addition, we need to evaluate the first sub-expression. When we evaluate the first sub-expression, it's what? Identifier introduction. Then, when we have val x equals the first sub-expression, evaluated. 1 plus 2 is 3. So x's value is 3. Remember that when you evaluate the second sub-expression. It's an addition of x and x, meaning it's an addition of 3 and 3, which is 6. What's the value of this second sub-expression? 4 minus 3, which is 1. So this x is 1, this x is 1, 1 plus 1 is 2, so 8. Yeah, again, we need these. So far, so good? Right? Then, what about this? Yeah, sorry about all the typos. I'm gonna fix them later. What about this? Previously, it was x. And I was using 2 x's here. I was using, many x's. How many occurrences of x here? 1, 2, 3, 4, 5, 6. Are they all the same? Not really. What are the same and what are not? Let's try. This is an introduction place of x, right? And this is a use side of this x. This is a use side of that x. Now I'm introducing another x. This is different from that x. So let's color it differently, like this. Because this x and this x, that's green x and blue x are different. What is this one? Is that green x or blue x? Blue x, right? Because they are enclosed by these braces and they are enclosed by these braces. We call that scope. And we're going to talk about scope later. Okay, one more time. Here we have this first scope and we have the second scope, meaning that this x is available from here to here, yay, right? And this y is available from here to there. So when you say y here, we know that's this. When you say y here, we know that's here. When you say y here, then we're gonna say, what are you talking about, right? When you say x here, we say it's a free identifier. Oh yeah, right? Then, so even though we renamed x to y because they are just the same thing, it evaluates to the same value 8. So before moving on to the next slide, let's resume. Let's remember what we learned just before the break. Remember? Do you still remember? We talked about binding occurrences and bound occurrences and free identifiers. Can you see that? Yeah? What are binding occurrences? This x and this y. What are bound occurrences? This x and this y. What are binding occurrences of bound occurrences? What? What are binding occurrences of bound occurrences? For those bound occurrences, they should have their own binding occurrences. Hey, you x. Hey, you y. You are not alone, right? You were introduced by some binding places. Where are they? Here. And there are no free identifiers in this example. So far, so good? What about this one? Does it look like a bit different? Previously, we had 2 curly braces, but they were in the same level. Plus was in the middle, and the first thingy and the second thingy were in parallel, right? Just in the same level. What about this one? Ooh, one is nested. One is nested inside the other, right? This scope is embedded or nested inside the outer. That's outer, that's inner scope. Okay, so let's see what it is. In the beginning, x's value is 1 plus 2, which is 3. Yeah, you know the value. That's 3. What about this one? What is it? It's X again? Oh, there are so many characters, but you are still using X? Okay. And the value of this X is 4 minus 3, which is 1. Yeah, here it's 3. Oh, now use case. What is this X? Do you want it to be this one or that one? How about that? Do you want it to be this or that? We discussed this just before the break, remember? Right? Because we want to be fair to both axes, you may want to say this one is that one and this one is that one. Wow, that's maybe fair, but a crazy semantics. When you say X in this one single expression, they better denote the same thing. As I said before the break, there could be several options. There could be several different semantics. One may be more obvious than the other options, but it depends. Your mileage may vary. People may think differently. So one language could reject this line. Hey, what are you talking about? X is already declared here. You are not supposed to declare the same name in the same scope. I'm gonna reject that. That's one semantics. Another semantics could be what? This one came first. Yeah, so you just, yield the scope to that one. Outer one wins over the inner one. That's another option, but I never saw such a language, semantics. Usually, inner one wins over outer, meaning inner one hides the outer one. Inner one shadows the outer one. So this X shadows this one, and then because this X is closer to this, 가까울수록 친하잖아요. So meaning that it's 1 plus 1, which is 2. Are you with me? Yeah? So far so good? So even though they have the same name, this X refers to that one. So even though this was introduced already, but it never used. Oh, then let's do that game one more time. Binding, bound, and free. Okay? So you should be able to play this game with many examples, more complex examples. But this one is not that complex. Let's try. Binding occurrences. How many binding occurrences in this code example? What do you think? There are, 2 binding occurrences. This one and that one. Okay, good. How many bound occurrences in this code example? You need to think. How many? Yes, 2. This one and that. Then, hey, those x's, little x's, what are your binding occurrences? Then you should be able to draw arrows from binding to bound, or the other way around. But I already said. So arrows from binding to bound, meaning binding to bound. This one is a binding occurrence, but it does not have any bound occurrences. Again, this example does not have any free identifier. Okay, are you with me? Then let's try this. Oh, similar but different. We introduce a name X here, whose initial value is that. We introduce another name Y, whose value is that. And then we are using X's here. Oh yeah. What's the value of X again? 3. What's the value of Y? 1. What's the value of X again? 3. What's the value of X? 3. So the value is gonna be 6. Right? Again, the game again. Binding X and Y. Bound X and X. This time from bound to binding. Yeah, right? You need to read the problem clearly. From what to what? It depends. It depends on the question. So you need to read questions clearly What I just said was what? Bound to binding. Then, yeah, from bound to binding here. It's not here, right? Because they are different. X to Y doesn't make any sense. So, this X is from that. Not difficult, right? So, now that you must be familiarized with this example, let's review one more time. We defined a new language called Expert. Expert is a set of expressions. In this expression, in this language, there are 5 ways to create an element of this set. A number, an addition of 2 expressions, subtraction from one expression to the other, and introduction of a name whose value is the value of the first sub-expression separated by semicolon and the second expression. And this one is enclosed by curly braces instead of parentheses in addition and subtraction. It doesn't really matter. Again, these are what? Concrete syntax. So whether you use parentheses, curly braces, or square bracket, I don't care. But we just wanted to help you to see the difference between just arithmetic expressions and making a block, a sequence of expressions. Even though Scala and some cool languages do not require semicolon, the parsing is a bit beyond your league, so we require you write this semicolon between this expression and the other one. One more time, the semantics of this identifier introduction expression is first, evaluate the first sub-expression, get the value. Let's call it V1. Then the value of ID is V1. Remember that because when you evaluate the second sub-expression, you may need to name this one in here. If you see this name while evaluating this one, the value of that thingy is V1, right? If you don't see it here, okay, so that's not a problem. And the value of the whole expression is the value of the second sub-expression. Okay, we can define or we can describe this concrete syntax in Scala abstract syntax in this way. Blue things are just as before, and red things are new. For name introduction, we need a name in string, the first sub-expression for initialization, and the second sub-expression for the body. ID, it has only one field of type string to represent its name. Again, parser is given. You don't need to know what that means. And just as before, you can create abstract syntax by using those constructors. As we saw here, this val, as you saw that, here val takes a string name that we are introducing, and the first sub-expression to denote the value of x, and the second sub-expression to denote the value of the whole expression. Now, exercise number 2 is available. It's available from Piazza as usual, and we are not going to grade your exercise solution. As I explained that last week, we used to have 10 or more homework and grade them and gave you some tests, but because there could be some solutions out there that are not fairly distributed between students, we decided to make them exercises and give you guys solutions in a week so that you can study. So you may want to wait till then and just look at the solutions. That's not gonna be helpful or useful to you. I strongly recommend you to do that this week so that you can decide whether you're gonna drop this course or not, right? So I strongly recommend you to do this by yourself this week. References of identifiers are again available in Korean and in English. Next up, the Scala session. This is the last Scala session. Today, we are going to talk about pattern matching and options.